Okay, probability and normal distributions. In this video, we'll find probabilities for normally distributed variables using your calculator. So in this video, we will take real-world application problems that involve variables that are normally distributed, and we'll be able to find probabilities that these variables will occur. What you do is you have to first convert the upper and lower boundaries of some interval for the value x into z-scores, and then from there we can find the probability that that event will occur. Now, what I just described to you is if the calculator did not exist. So we'll be using a normal distribution table, but we ultimately will be using our calculator for this, but I'm going to show you one example of how to use the table. So the steps for finding probabilities with normal distributions are the following. The first thing I want you to do is sketch a graph and shade the appropriate area that you're trying to find. Then for step 2, if you're using a table, you're going to find the z-score that corresponds with the x variable. That would be by using a formula that I'll give you in a moment. And or if you're using your calculator, then you will use normal CDF. Again, you'll do the lower boundary, comma, the upper boundary, comma, the mean, comma, the standard deviation. And then the last step is you will find the area under the curve, otherwise known as the probability of that event. So let's do an example problem. So in this problem, a survey indicates that people use their computers an average of 2.4 years before upgrading to a new machine. The standard deviation is 0.5 years. A computer owner is selected at random. We want to find the probability that he or she will use it for less than 2 years before upgrading. We want to assume the variable x is normally distributed. So important pieces of information here is the average or the mean is 2.4 years. And the standard deviation is 0.5 years. So when I draw my sketch, the mean is 2.4, and one standard deviation is 0.5. You don't really need to draw in 1.9 and 2.9, but that gives us reference to where the 2 is because we're interested in less than 2 years. So it's going to be about here. That's where 2 is, and we want to find this area of this shaded region. So we have our sketch, and the next thing we want to do is calculate the z-score for this x variable. Well, the formula for that is x minus the population mean divided by the standard deviation. This formula converts x values into standard normal curve values. So we're going to do 2 minus 2.4 divided by 0.5, which is negative 0.80. So in a standard normal curve, this value right here would be negative 0.8. So then the next thing we do is we use a table, which is over here, a standard normal table, and you find the z-score, which is negative 0.8, and it's negative 0.0 or 0, so right here 0.2119 is the appropriate area, that guy right there. So let me go back here. So that means that the probability of a z-score being less than negative 0.8 is 0.2119. So the probability that the computer will be upgraded in less than 2 years is 0.2119, or we can think of it as a percentage, 21.19%. So let me just write that as a sentence, 21.19. Oh, I should do it to 3 sig figs, so 21.2% of new owners will upgrade in less than 2 years. Okay, so that's how you use a table. I'm going to do the next example using the calculator. So for this problem, a survey indicates that for each trip to the supermarket, a shopper spends an average of 45 minutes with a standard deviation of 12 minutes. The length of time spent in the store is normally distributed. Find the probability that a shopper will be in the store between 24 and 54 minutes. So the important pieces of information is 45 minutes is the average, is the mean, and the standard deviation is 12. And I want to find the probability that will be between 24 minutes and 54 minutes. So this probability, this interval. If we were doing it by hand, we'd have to find the z-score for both 24 minutes and 54 minutes. But we're going to do it on a calculator, which is super awesome. What we're going to type into our calculator is normal CDF 24, 54, 45, 12. So lower boundary, upper boundary, mean, standard deviation. Okay, so here we go. We go second distribution. We go to normal CDF. We do 24, 54, 45, 12. Press enter and we get this probability right here, which is 0.733, and we'll do it to 3 significant figures. So the probability that the shopper will be in the store between 24 and 54 minutes is 0.733 or 73.3%. So let me just write that as a sentence. 73.3% of the shoppers will be in the store between 24 and 54 minutes. If 200 shoppers enter the store, how many would you expect to be in the store for that interval? All I do is I take 200 shoppers and I multiply it by that probability, which is 0.733, and I would find out how many would be in the store. I get 146.6. We can't have 0.6 people, so we round down to 146 people. The reason why we round down is we don't have a whole person, so we have to not include that 0.6. Okay, that's it for this video. Good luck on the practice problems.